I think you can see my screen now. Perfect.
Yes. Yes.
So hello everyone. I'm Magelos Sideris from UPRC. I'm here to behalf of Rescale project and will present you about the functionalities, how we can have some synergies on later steps of the project or with CHRISS or with other projects that will be represented today. So the Rescale project kind of contributes to securing supply chain. That's the main purpose. It's an area that it's increasingly important about regulatory efforts, especially with Cyber Resilience Act, and particularly relevant with the IoT ecosystem. So let's go to what is this project. Uh, the Rescale project develop like methodologies and tools to validate and assure security across all the stages of the digital supply chains, let's say. Well, it's on IoT exclusive project. It can also address some technical problems like the CRS I mentioned previously and can regulate the whole process of the supply chains also applied in IoT. So what has been done about in this project or the key principles I saw in my presentation? We have developed a secure by design supply chain. So we integrate security controls uh, through the whole process of the sourcing, building or delivering components uh, or anything. We use verify suppliers with cryptographic signings. We also automate the evaluation about both software and hardware components. We use static and dynamic analysis to check about dependencies or do some scanning and hardware validation process with specific frameworks. I will be more detailed later on. We also enforce a third-party supply on supply chains to validate a vulnerability-free process through all this. We monitor or we can achieve that with using non-vulnerabilities like the CV from specific databases. We also provide an effective audit procedure, especially for cybersecurity testing, with some standards, with some principles and some policies to check how it is automated properly, to create a reporting, and also ensure that the code or the software it is developed can have some aspect like access control and supply chain dependencies. And lastly, we uh, enable on construction of securing system with the strongest possible guarantees. So with our software, we are implementation, we ensure that we have a secure architecture, first of all, in principles. We have strong privacy and isolation processes, and we are using cryptographic integrity checks for all this. So let's talk a little bit about the project and the consortium. As you can see here, there's a consortium with 15 partners across 11 countries. As you can see, the UPRC is on top right. So this does not include only academic institutions like universities. We have a balanced mix of also academic and SMEs and also some large industries to ensuring both excellence and also area war impact. So to check it somewhere that is relevant. Let's talk a little bit about the motivation. What is the purpose of this project? How, what is the clear view and why it is important? So, so there is some challenges, let's say, to untrusted or poorly third-party components. And some of these common security issues are in the bullets. The current supply chain security approach is mostly on software centric. So it is not focused in other part, but like in libraries and source code, open source and stuff like that, leaving the whole idea of the hardware and the firmware a little bit unprotected. So we try to achieve something like this. So the current SBO I mentioned previously are some standards providing with the inventory indivisibility, but they are not have some strong security evidence to cover it to hardware chain or if the data or something has been tampered. So therefore, our project is motivating to shifting for a more trusted way that includes also security testing that we run and have a result and accountability account this process about hardware and software layers, how it is secure, how it is tested and have like a score to say. So how we achieve that? Not how we achieve that, what we're trying to achieve. With manual audits, they don't scale about size, about real world example like real supply chains. So the motivation was to include automated static and dynamic analysis to enhance it also with artificial intelligence, since there is quite common right now. It's a good way to use it in cybersecurity. And also we try to have a continuous cover around the life cycle of the software and the software and the hardware, I'm sorry. So the motivation was to create a continuous guarantee insurance about the validation, about the assurance of the security. So let's see like the toolchain or the architecture of this one. Sorry. So we have three basic components or three layers that we see in this presentation. We have the assessment domain. We have also the management and also how the user interact with this platform. And also lastly, we have the security and trust domain that we are using with ledgers. To have a more clear view, let's say a little bit from each of these layers. So first of all, about uh, the domain, we have static code analyzer. So that scans the software based on specific known vulnerabilities or like bad patterns with specific signature. We have a formal verifier that proves the correctness or the security properties of the software. And after that, it creates and generate or also create a static security compliance generation. So it documents the rules and how describe the components are verified and their properties correctly. We also have there a dynamic testing module that focusing mostly in real-time behavior, both in hardware and software execution. We use low-level hardware assessment, like inside the chips, the firmware, and specific dot. And after that, we create the dynamic security compliance guidance as it is with the static that it is stored inside the ledger that we can use. So the second part, the management domain, is basically how everything runs, like I said, the brain or the central part of this implementation. We have a dashboard that the user can interact with it, see assessment, see the result, and some policies we have already created. We have the state manager that tracks everything about the processes, the status, the workflows. And also we have some authentication authorization for the user and the tools. So how it is inside our network, how we can use it, or how everything should be inside. Like not every user has to be inside the network, has to be authorized and authenticated first, basically with if he has access to this purpose or if he can access specific functionalities. We have also the communication mechanism that's like the intermediate between the user and the dashboard with the ledger that we create to store data. And in the far right corner, we have the trust component that creates the trusted video of material, as I said previously, with some verified info and also check the authenticity and the correctness of these entries. Because if we don't have an authenticity or check how correct it is and if the process is correct and run as it should be, that would be a little bit of an issue. The last part is about the ledger. There we store the data or the outcomes of the whole process to access it later on through the repositories and create a better or real-time results. So let's see a little bit of the correlation between the two projects. The Rescale project, mostly or the biggest part of it that we don't use in CHRISS about software. We use static dynamic security analysis and some testing to create and validate the process of the software and the hardware. So that's a bit of component that we can use inside our project if needed in later steps. And about also the GNSS and how we can connect and communicate these two projects. About the GNSS can take part in a critical way in the supply chain, like in real-time tracking goods. So we can enable where the goods are in, about the shipment, the containers, or the vehicles. We can also see with the GNSS some part of like incidents that may happen, a crash or whatever about the vehicles, and check about the maybe probably delays of it. And also we try to, we can create a more correct and more full assessment of the whole process in order to create for the user and the clients a better experience. So let's see what we have created and how they work. It's a little bit about having the components. We have created something called SASTER, is a static analysis security testing engine. And also we have an intelligent vulnerability exposure. The first part about the static analysis, it's kind of an integrated offline framework that used to static analyze the code and the security purposes. So the components enter the supply chain, it processes and detects some vulnerabilities, and can real-time present result like the earliest possible, let's say the stage of the whole process to see when they're easier to fix or make modification. As you can see, we can support multiple uh, module like these ones that referring here in this presentation, and also we use multi-language coverage about the supply chain software. We can see C, C++, Java, Python, stuff like that. And as I mentioned, the goal is to have an early detection about the code level of vulnerabilities before integrated to the supply chain. So before we establish everything, we need to check it and validate how it works, and as security matters are compliant and stuff like that. And also we have the intelligent vulnerability exposure engine. That is like a compact execution, like a modern software for the supply chains to have code base like the ones we previously mentioned. So it checks and explores the programs, the path, and generates inputs about hidden bugs, something we may not find with the static analysis. And also it targets the vulnerability patterns like buffer overflow, as we said, in a low-level hardware part, the paths, the commands and stuff that is more in the hardware component. And also the goal is to have a static checks with high precision vulnerability discovery. So to have as good as possible coding a hardware interconnection. So the last part, let's see how can see this purpose in the future about the IT. So it was built to a scale project, and everything inside was built to secure the supply chain. Now the tools are naturally aligned with the CRA and the concept of IT, where it is excited and contribute to a more resilient digital ecosystem. Because right now everything is running in the IoT part of the internet. Everything is interconnected. So the results can support a real-time work development in IoT, both for industrial and also for the embedded system. And it can contribute to shaping a more secure and transparent way of accessing the supply chain, and also about the security in it. So this is my presentation. I don't know if you have any question or something needed to be clarified. Feel free to ask me. I don't see any questions, so I think we can.
No, yeah.
The next